Hi everyone. So now we're gonna start. Nice to see you all. So just to clear out a bit, this is gonna be 3D basics for TouchDesigner. I will just explain like the basic the basics of 3D modeling, or not modeling, but in general, and see how we can apply that in TouchDesigner. I saw that last time it was really basic, so we're gonna do the same, take it really slow. And if you want to go a bit faster, just let me know. If you have questions, just ask. I'm here for that. Yeah, that's about it. So let's start. So what's a 3D object? Basically, a 3D object is an object made out of points, and those points basically are linked together with a plane. So you have, let's say, if you want to have a triangle, you have 3 points, and then you have a plane, lines and a plane that are basically linking them together. And give me a second. So how do you apply that in TouchDesigner? So let's see. Gonna start the software and share my screen. So let's share the screen. Here we go. Good. Okay, so TouchDesigner. We saw that last time. I guess you install it by now and you have a license key. If not, you can still, go on Derivative website and get everything you need from there. I'm just gonna cut the Discord sounds because it's getting a bit annoying. So, okay, that should be done for the notifications. Oh, good. All right. So what's a 3D object? In TouchDesigner, it's gonna be all the objects that are in the sub menu. So not all objects, but a lot of them. So let's see. A box is an object. So remember, you can zoom in, and if you want to activate the node or the module, so I'm going to use node, module, or operator interchangeably because it's basically the same. So yeah, in this case, we have a cube. And you can activate the operator by clicking the small plus here. And then you can drag and drop and turn and whatever. And you can see your 3D object. Then you have other operators, which is you have a sphere, which is also a 3D object. Now I'm turning it, but as you see, you don't really see it turning because you only see the axis turning. So the axes are basically where your 3D object is positioned in space. So you have XYZ axis. And in this XYZ axis, you position your object. So it goes from minus something to plus something. And it goes into the XYZ axis. So depending on the software, it's a bit different. In this case, we have the Y-axis that goes goes from down to top. So I think it's vertically, right? I always have trouble with this. I think it's vertical, exact. Then you have the X-axis that goes horizontally, like this. So you have Y-axis, X-axis, and then you have the Z-axis, which is basically going like this. So it's a bit complicated. I don't have enough hands to show you like this, but yeah. So basically, in this space, you can put 3D objects, and you can move them, and you can scale them, you can rotate them, you can do whatever you want. All right. Next 3D object that we have in here. So we have the sphere, you have the cube, or a box as they call it. You have the tube, which is basically just a tube. Then you have, what else do you have? You have the grid, which is basically a plane with, yeah, it's just a plane. So it's just like a sheet of paper, you know. It's just like a two-dimensional object for now. Two-dimensional because there's nothing going in the third dimension. So in this case, there's nothing going up or on the rather on the z-axis. So yeah, it's flat basically. Then you have all the other two-dimensional objects, which is like the circle. What else? The rectangle, which is basically a square or a grid, but with where you can change the width or the height. So a rectangle. What else? You have also a simple line. You can just create a simple line. So yeah, not really exciting. I mean, as on its own, but you can do a lot of stuff with it. Okay. And I think oh no, you have the torus, so also called a donut. So basically, it's a pretty cool object, pretty standard. In TouchDesign is one of the standard objects. So yeah. And I think this is basically everything you have as objects inside TouchDesigner. So you can have a lot of different other objects, and you could just import them. So if you want to have another object, so the workflow would be like that: create a 3D object in Blender, Cinema 4D, Maya, whatever your choice of 3D modeling software is. And then you can import it into TouchDesigner and move it into space, scale it, change the texture, change the lighting, etc., etc., and all in real time. So what does it mean to this? What does it mean? What does real time mean? I guess some of you remember from last time, from the last session, I was explaining the difference between like a 3D modeling software as Blender or something that is not a 3D object modeling tool, but something else like TouchDesigner. So in Blender, you can model your 3D objects. I mean, if you want to create a headphone, you're gonna model that in Blender and then import it into TouchDesigner. The big difference is how fast these are actually rendered, so put out on the screen. So in Blender, you can have usually you have to wait like say between 5 to 10 minutes to 20 minutes to 8 hours to 48 hours until you have a really nice rendering. In TouchDesigner, you can do that 60 times per second. So and that comes with a set of compromises. As you can imagine, you cannot render something 60 times per second at the same quality as something that has been rendering for 48 hours, let's say. So a lot of things that are possible in Blender in terms of quality are not possible in TouchDesigner, and a lot of stuff that is possible in TouchDesigner is not necessarily possible in Blender. Yeah. So if you want to create like interactive installations or you can do also 3D work, obviously, in TouchDesigner. And what else? Yeah, that would be like the biggest difference is really how the speed of rendering and the quality of rendering. The rest is really up to how you want to work. And also, TouchDesign is not a modeling software, so you cannot really model like complex geometry. So you cannot model complex 3D objects in TouchDesigner. But you can have like cubes of cubes or things a bit more complicated, but not as far-reaching as Blender, let's say. But the principles still apply. It's in the end, it's still 3D. The principle apply to 3D in Blender, they will apply in TouchDesigner. Just the quality won't be the same, and you have to be careful about speed in general. Yeah. So as for the general overview in 3D rendering, how does that work? So you have let's say a 3D object. You have those headphones, and right now you have a camera that is looking to the headphones, as you can see. So the camera would be my webcam. On this 3D object, you have textures, you have materials, various materials. So you have textures that are like, I would say, like the logo it could be a texture. Here you see you have materials. So this is like plastic, this is metal, this is another type of fake plastic or fake leather rather. This is some foam. These are characteristics of materials, and they have also like the physical characteristics of materials. So are they opaque? Are they shining light in a certain way? Or are they black? Could they be red? Could they be shiny? Could they have like this little bit of let's say texture? So yeah, and then this 3D object are put into a scene. So in our case, the scene would be my head, the headphones, the door, and the everything that is in the background. You have the camera looking at it, and then you have also light coming from the various lights that are inside my room. So you can see depending on how you turn your 3D object, you're gonna have different lights. So you can see this is the light from the screen. You see it shining from here, and if I turn it, there's another light coming from another side. So like the real basic setup of a 3D scene is a 3D object, a camera, so a 3D object with its characteristics, so the way it looks, the way it feels, the colors, and then you have the camera looking at it, and the lighting that is around that shines a certain light on the 3D object to make it look in a certain way. Yeah, so that's really the basic components of a 3D scene. Yeah, and then you can animate the camera, you can animate the 3D object, you can make it bigger, smaller, go up and down, left, right, front, back. I mean, the possibilities are endless. In terms of lighting, there's also lots of different lighting. There's like maybe 3 or 4 really main lighting types, and then you can mix between all together. If you've done a bit of photography or video, that's really helpful. So you can see how to position the lights and make it the best way, the best looking way, make it look the best way. Also, if you're really interested in 3D objects and 3D modeling, I would really recommend you to do some photography actually, because simply you're gonna learn how to work a camera, which is the same as in a 3D modeling software. You're gonna see how the lighting are influencing the objects, see how different objects have different properties in terms of materials and textures. Yeah, I can really. I mean, I've done like I've done quite a bit of photography in the past when I was a student in design, and that's helping me actually now also to have better figure out how to do proper setup, lighting, and scenes and everything like that. So real world collides with the 3D world, and both are really linked. And the better you understand the real physical world, the better you're gonna understand how to work your cameras and your 3D stuff and everything, blah blah blah. So also, if you've done short movies or whatever, it's really beneficial to learn this kind of stuff. So back to our objects. So yeah, these are the basic objects you have in TouchDesigner, and that's already a lot. You can already use them for to create art, to basically to create art actually, because this is what you want to do, I guess. I'm just gonna set up like a really basic 3D scene, as I was saying before, using all the components I was telling you. So for a proper 3D scene, we need one, an object, two, a camera, three, we need some lighting, and the fourth, I'm probably missing something. This is like, so you have geometry. Oh yeah, we need the object, the camera, the lights. Basic setup. Same for all the 3D modeling software. In our case, we're gonna use a cube or a box, as they call it. So the box, simple box, yeah, and then you connect this. So you have the 3D object, but then you have to connect it to an operator that is called geometry, which basically handles any 3D object that is connected to it. So if we want to use this cube, you set up this cube in TouchDesigner. So you double click on the plane of work plane. Double click, you click on box, and there you have your box or cube. Then if you want to add like the geometry node, you right click on those two small bars here. So right click here, and then you can add geometry. So there we go. So now we have our 3D object that is represented by a cube inserted into a geometry operator, which is going to be the base for our scene. So remember what I was saying before? The cube is the headphones. So now we took the headphones, we put it into the scene, and now we need to add a camera and some lighting. Okay, how do you do that? So double click on the work plane, add camera. Same for the light. So double click, add the light. And now that we have all the components, the next thing we want to do is to actually render it. So what does rendering mean? Rendering means that you're gonna take a snapshot of the geometry that is in the scene at that exact point of time. So that exact point of time in our case is 60 times per second. So you take a snapshot of the scene 60 times per second. And to render our box in this case, you double click, you go to top, which are all the image-based operators, and you click render. And there we go. We have our cube that is rendered by the camera that sees it, by the light that is shining on it, and the 3D object that is here. Okay, I'm just gonna pull this up here. Any questions for now? All good? You can talk on the Discord channel. I'll look at the picture at the questions and everything, in case. Okay, so nothing yet. All good. All right. So the next thing we want to add to our 2D object is well, maybe some color, because right now it's just like it's just a gray box, so it's not really interesting. So if you want to add something to a 3D object, as I was saying before, just still taking the examples of the headphones. The headphones, they would be this light gray if we didn't add some materials or some textures on it. So I'm just gonna add the material on the 3D object that we have in front of us. In this case, we have the box. So double click, you go on the matte tab, and there you see you have various materials. I'm just gonna go through like the main ones, maybe a couple of words on the other ones, and tell you and let you know what is actually the ones you can use like now. So a constant material is constant material is basically that would be something that like this post-it. So this would be a constant material. It's all one color. Yeah. So if we add a constant material to our 3D object, you're gonna see. I'm going a bit fast because I'm so used to it. So it's really like instinctive. So I'm going to go a bit slower. So how do you add the material to the geometry? Well, you take the constant and you drag and drop it on the G1, and then you select material, and there you have your material that is applied to our 2D box, and this is our first material. As you can see, there's no lighting applied because there's no there's no lighting basically with the constant, because there's nothing to reflect the light, there's no grain, it's not shiny or whatever. It's a bit hard to explain in real life what it is, because it doesn't really exist in real life. There's such a constant material, except like something like the how is it called, this black pigment, which is 99% or 99.99% black, and it doesn't reflect any light. But any other object will reflect light in most of the environments you have. And this is the same with this. So it doesn't reflect light, so there's no shininess. It doesn't look like anything. Okay. If you want to change the color for this constant, you click on the operator. So the constant operator is gonna highlight green, and then you press P. So on your keyboard, P, and then you have all the parameters for this particular operator. And all operators have a certain amount of settings or parameters that you can change to make them behave in a certain way, to make them look in a certain way. So in this case, I just want to change the color of this material from white to red. So you just click color, select the red, and here we go. We have this constant material that is basically red now. All right, so that's the constant material. Yeah, can be useful in situations where you want to have a 3D object that ignores the light, or you don't have a lighting in your 3D scene or whatever. There are some cases where you need that. Okay, next. what you have. So depth is basically depth information in your scene. So it's how far the objects or the object is from the camera. So in this case, I guess you won't use it directly. So I'm just really skipping a bit fast on this because it's just like more conceptual. So it just shows a grayscale image of where are the the, the points that are the nearest to the camera. So if you have a point that this point is the nearest to the camera, so it's gonna be dark gray, and this one is this one in the back is one that is furthest, so it's gonna be white. So you have like a depth information, so you can actually see how far the objects are from the camera. Okay, GLSL is just a kind of programming language that you can use to program small software that work on the graphic card. So it's a bit too complicated for now. In is just is to create an input in a component, but it's not really relevant for us right now, so I'm just going to skip it. You have the line material. So as it says, it's going to transform our 3D object to go from having being fully being full like that, being fully rendered. So you have like a surface to just the 4 points of the object that are and linked with lines. So demonstration is better than an explanation. So drag and drop onto the geometry material, and here you can see you have your 3D objects. Yeah, you have your 3D object with the lines material. Just give me a second. Okay. And this you can use with all 3D objects. So if you have what you see in the what you see here is basically a torus or a donut, and that's the wireframe of it. So it's the internal structure. So using this material gives you an insight how the 3D object is basically structured. So in our case, a cube is basically really a lot of points that are linked together, and you can have more or less points. Not less points, because then there's no cube, but you can have more points. Okay, so next one would be, okay, I was just checking if there's some questions. Give me a second. Okay, no questions. All right. Okay, null. Okay, I'm gonna skip over the few things. So null, no out, no. PBR is probably the most complicated one in TouchDesigner. The real name of or the long name of PBR is basically physically based rendering, which means that it's going to be the closest to what you can see in reality, because as 3D rendering is mostly really based on math. There are various ways of depicting the reality in with mathematics. And the PBR is the one that is the closest to reality, because you can have different maps, which are also which you can call textures or images. So a map is the same as a texture, and it's the same as an image, more or less. There's like some difference, but at your stage, I don't think it does really make a change. And each of this image or texture adds a different layer to our 3D object. So you see, you have like so you have the base color, which is the black of our object. You have the specular level, which is basically how the object reflects light. So in this case, you have different types of materials which have different properties, and they reflect the light not in the same type. So that means you would have different specular levels on this 3D object. Then you have a metallic map, which basically is applied as how shiny it's going to be, how metallic it's going to look like. It's a bit complicated to understand, but if you work a bit with it, you're going to see the difference. Then you have the roughness map, which is basically how rough the texture, the material is going to be. So is it a bit grainy? Is it completely slick? Is it like more of like a phone, like really slick, or is it a bit more rough, like the headphone pads, which have some bit of texture? Yeah. So what I'm saying texture in this particular case is not an image, but it's more the feeling. So you know, is it gray? Is it a bit grainy? Is it a bit rough? Is it what is the feeling on your hands when you pass it over? Then you have the ambient occlusion. So don't get too stuck on the names. The best way to learn about this is to really try out. So in this case, the ambient occlusion is how the shadows are looking on your 3D object. So are there going to be like small shadows in between those two pieces? Maybe an image speaks a bit more. Let me check if I can find something. Oh yeah, okay. So here you can see. Can I have it bigger? So the ambient occlusion on the left one, you have basically no ambient occlusion. On the right one, you have with ambient occlusion, which gives you information about how the light is looking between the different elements. But you can work without that. Then you have the normal map. Normal is a normal in the 3D world is basically how which direction the light is going to be reflected when it bounces off the surface of a material. When you have material, the light will come this direction. It comes from a certain direction. And the normal map tells you if it's going to be go like this, or if it's going to go straight back, or if it's going to go in this direction, or whatever. And it's going to give you like the direction of the reflection in the 3D object. Yeah, normal maps. Normal. All right. And this is for the physically based rendering material. So that means you can have a lot of the characteristics of real world integrated directly into your material. Yeah, and also you can use something that is called Substance, which is a texturing tool where you can create all those maps, so all those textures, and then you can import it in TouchDesigner and use it on your 3D object. Yeah. Any questions right now, or all good? Okay, all good then. Next we have the Fong. which is really the most basic material you can have. This one is not physically based, so it's a bit more approximate. It doesn't look necessarily real, or it doesn't look real in the way that it's not mathematically correct, but it can still look real. I don't know if you get the difference. Yeah. So if you want to use it, as I said before, drag and drop on geo, param material, and then you have it. You have your 3D, your Phong material that is applied to your geometry. So, and Phong basically comes from the person who invented the algorithm for these materials. You have a few. You have Gouraud, you have Phong, you have the PBR is also an algorithm. Yeah. So when I say algorithm, is the mathematical representation of how the material works behind the scenes. So yeah, if you're really deep into it, you can code your own materials and do your own reflection models and whatever, and see, and you can do lots of different things, but that's getting really deep into it. And again, if you want to change the color, in this case, you have different types of options, which are a lot more. So in this case, we have diffuse. So basically, diffuse is the general color of the object. And why is it called diffuse? Because when a ray of light hits upon that material, it diffuses a certain color back. So in our case, we're gonna have red, or green, or purple, or whatever. Yeah, you can see you have the light that is shining, and you have a little bit of reflection here, and you have the light. So our light is basically so this is our 2D object, and our light is here, so it goes like straight like this. Then you have specular. So as I was saying, is how strong the light is reflected by the object. In this case, the strength is given by a certain gray. So if you want to have it like really reflective, you put it to 1. So it basically reflects all the light that is being shown at it. And if you want no reflection, you put it to black, and it's going to be the same as the constant material. There's no, the light doesn't it's not reflected by the object. Okay, so I'm going to keep it like as a certain gray. Then what's the next one? Emit. So emit, emission. It's the emission is when an object emits a certain light, so from itself. So like a light bulb emits a yellow color, it's going to be the same for this. So you have, if you wanted to emit a certain color, you can have purple or blue or whatever. In this case, you have to also, there's a certain thing you have to remember, is that emission is really strong. So if you put it on white, there's no reflection, because all the object reflects more light, emits more light than it actually reflects. So there can be no light reflected basically. So yeah. So you can have a mix. So the lower the emission, the more reflection you're gonna have. Yeah. So I'm just gonna keep it at black. So there's no emission at all. the box doesn't act like a light bulb or whatever. Then we have constant. Constant is going to be the same as the constant material we have. So if it's black, there's no constant applied to it. If it's going to be pure red, it mixes up with okay. I have never really used the constant one, so maybe I'm saying something stupid. Yeah, just forget about this. Yeah, you can live without using the constant, to be honest. Shininess is how shiny the object's gonna be. So it's a bit like yeah, I was saying with the metallic map. It's kind of the same, kind of. And then you can have something called a color map. So in this particular case, I'm just gonna add a 2D image. So if you want to add a 2D image, you double click on your work plane, you select movie file in, and that's how you import an image or a video or whatever. So I'm just going to use the banana because it's just the one that is just there. And I'm going to add this banana to our 3D box. So you click movie file in, you drag and drop onto the color map, and you can see we have the banana that is put on our 3D object with the color that is being used currently. Also, as the image is transparent all around, that means that the cube is going to be transparent where the image is transparent. Maybe I'm going to use another image because it might be not so clear. Give me a second. Let's use a flower. Okay. Yeah. So we have this flower that is added to the material, and this material is then put onto the box, and on the box there's this flower. So if you rotate the box, you can see you have the material being applied to the image being applied to the box with a bit of shininess, which you can with a bit of reflection that you can see here. And if you want to have the image as it is, you put the diffuse to white. So there's no added color to our texture if you put diffuse to white, which you can see we have the exact same texture image that we are putting in here. All right. Then you have the more normal map again, which is the way how light is reflecting. Maybe I can show you quickly. So you have something that is called a normal. Where is it? When I'm looking for it, I'm not finding normal map. Exactly. So you have an operator that is actually that is called normal map, and that allows to create a normal map out of a picture. So if you want to connect this one to this one, you just drag here and you connect here. So you can see it looks a bit weird, but each of each of the colors basically show you the direction of the lights. So how it's gonna look like if you shine a light on as a 3D object. And then you connect and you put that normal as a normal map, bump map. It's also called bump map, which is basically the same. And you enable the. You're not gonna see a lot right now because yeah, it doesn't show a lot. It's really discrete kind of effect. Wait. Oh yeah. Oh, first warning. So that's interesting. Also, you can see you have a small triangle like the warning sign up here, and if you click on it, you you're gonna see there's normal mapping inside our material. So there's a texture that gives us a way to see how the light is reflected. But our object does not have tangent attributes. So explaining what tangent is might be a bit too complicated. So I'm just gonna do exactly what they say. So tangent attributes can be created with an attribute create sub. So what is the attribute create sub? So to add an operator between this one and this one, you right click on the yellow line, insert operator, and then we're looking for attribute create. So basically the 3D object is missing some settings, some parameters, which allow for the correct calculation of the light reflection on the 3D object. And we're adding these attributes with this attribute create. So you click compute normals, compute tangent, and then you see a warning is gone. And yeah, and if you look closely, it's not really perceptible. Can I show it some more? Here. You can see the light is shining a bit differently depending on where I look. So here you go. See, you can see actually the details of the details of the image in the texture. It's the same here. So it's basically just it's shining where the image shows it to where it should be shining basically. Yeah, that wasn't really clear. Sorry. So yeah, it gives indication of where the light should be shining. In our case, everything that is covered by this normal map is shining in a different way. So you can see there's also a bit of 3D effect here. Yeah. And then you have, when you add a normal map, you have something that's called a height map. And a height map is basically a way to add some 3D information to an object via a texture. So if you have if you have this part and you have the logo here, you can use a height map to make it like a bit in 3D, like a bit of you put the logo a bit higher than the rest, and you can do that with the height map basically. I can show you. So usually a height map is an image that is grayscale, so so just black and white. And there's a really easy way to create a black and white image in TouchDesigner. So double click, and then there's the Monochrome operator. You connect the flower image to the mono one, and here you see you have an image that has no colors. And this can, in turn, be used as a height map, which we're going to apply. So you enable the height map, add the height map here. And if we turn a bit, yeah. And you have to, whoop. Okay, so it doesn't look like much, but there's something happening. Yeah, you can see actually. There's more ridges here. And it should be same with, yeah. So this is what the height map makes. It makes it a bit higher. And okay, so this is a bit more complicated, but when you use a Heightmap, it doesn't change the shape of the object. It's just an effect. So it's just it's just an optical effect basically. It means that the the computer is gonna calculate how it could look like if you change the form to a 3D object and to actually change the shape of the 2D object, you need more points on your 2D object. So as I was saying at the beginning, our box just has what? It's 4 by 1, 2, 3, 4, 5, 6. It's what? 24 points. It's actually more, but let's say there's 24 points in our cube. And that means we don't have enough lines going through the object to actually change the object if you click on displace vertices. So displace vertices, as you can see, if you click on this, it changes the object, but it doesn't change it as you want it to be. Because as you can remember, this box just has like 24 points. So if you want to have more points in our box and see how this looks with more points, you go on box, and you click on divisions, and everything fails. Okay. Yeah, the box is a bit different. Let me try something else. I'm gonna use a plane instead. It's gonna be easier. So click on SOP, use a grid, and replace that box with the grid. So here, yeah, and you can see already it's looking different. So you can see that our height map. So this image, black and white image, is basically deforming our plane. So the darkest points are the highest points, and the whitest points are the ones that are the lowest, if you can see. So darkest points are the flower, and lowest points are the green stuff. And you can see it's already being the height map is already deforming the image. But we want to have a bit more detail. So you go into the grid and you add some rows and some column. So you're gonna add more detail basically. I'm gonna go for 200 and 200. And you can see it's already looking way better because there's more information for the image for the height map to be transferred to the 3D object. And this is the other side, so the backwards side. Yeah, and then you have your display scale, and then you can change a bit how much it basically displaces it. So displacement is another word for distorting, or how much it distorts it basically. And obviously you can also change it by changing this image, because remember, this image is basically what is driving the transformation in our image, in our 3D object. Okay. And then you have, and the rest of the maps, well, you have a diffuse map, which is basically tells you where a certain color should go depending on the grayscale levels. So we can even use the monochrome image as a diffuse map, and let's see what happens. Yeah. So you can see that the points that are the points that are black in this image are the ones that have the less color in them, or the less shininess, and the ones that are whitest are the ones that have the most shininess in them. It's the same for the specular map. So that means you can really define which area should be a certain color, or a bit less saturated. And for the specular map is how the reflection is going to be. So you can have an area with zero reflection, and then next to it you can have an area with lots of reflection, and etc. etc. Emit map is going to be the same. So you can have if I'm using the same image grayscale, the emit map is going to tell the object where it should emit color and where it should not. So if I add an emit color here, it's going to show the reddest points where they are the darkest, and the ones that are we have a lot of different maps here, so it's a bit, but yeah, this is how it works. So you can see here the darkest areas are going to be the reddest. Maybe red is not the best one. Well, that doesn't work that too well, but yeah. So you can really define where certain properties for certain materials are going to be applied on your 2D object. Okay. And the environment map is going to be a certain way to light the 3D object. So I was saying that before, you have different types of light in a 3D scene or 2D environment, and those lights are basically here. So you have something that is a point light, which is basically just a point in space that shines lights all around it. So a bit like a star or like a sun. It's like sphere, and lights goes like this on all sides. Then you have a cone light, which is going to be basically a cone. Can I show them actually? No, I cannot. Okay. Which is going to be basically a cone. So I guess you know this better from movies or just basically lamps. I think all the lamps that are shining light from one point to another is basically a cone light, because there's one point and one direction of lighting. So you have your light here, and you have your direction of lighting, and it shines like this. And you have a distant light, which I'm not entirely sure what it is, but I've never used it either, so I don't know. And outside of this, there's other lights that are in 2D modeling software. So you have something that's called an area light. So instead of having a single point shining in a certain direction, you have a whole surface which shines the same lights on all the surface. So a bit like a spotlight they use for TVs or movies or photography, basically. So it's a real. It could be a square. It could be a circle. Yeah. Okay. And the last light that you have is called an environment light. And instead of using a light to illuminate a 3D scene, you're gonna use an image and use the light from that image to shine to shine a scene, to like illuminate a scene. So maybe I can show you what HDR, what the environment map is. Let's see. They're also called HDRI, and they usually look like this. Yeah. So this is basically an environment map. Sorry, environment map. And it means that the light that you see in this image is going to be transmitted on your 2D object. So you can see it here also. You have various types of materials. That's a good example for materials. So you have a glass material, you have a basic foam material, you have a metal material, and then you have some other shiny material. And you can see that the sun is at a certain point on the spheres, and it's coming from the light that is coming from that picture. So you can have different moods in your 3D scenes and have different reflections. So this is like an outdoor reflection type, and then you can have something that is more like a studio type of reflection. So you see the reflection is a bit different, and you can see the two lighting spots they use, or like the stage in the back and the background, and etc. etc. And you can have also indoor lighting, some really nice stuff here. Yeah, it's pretty cool for these kind of details, and you can use that in TouchDesigner. So I'm just gonna redo another scene. Sorry, so quick one. I don't need to explain that again. So I'm just gonna use a sphere. So double click, insert a sphere. Right click, geometry, camera, and a light. So and lights. Okay. So I set up the basic scene as I did before. Adding the render thing, and then I have to change some parameters because render basically renders all the 3D objects and cameras that are in your scene, and I'm just selecting the one camera and the one geometry and the one light I want to use in my scene. So you have camera 2. I want to use camera 2. I want to use geometry 2, so geo 2, and I want to use lights 2. Okay, basic setup as we had it before. I will add so I will remove this light and use an environment light instead. So remove, double click, go to comp and add an environment light. Okay. You see there's a small warning. It tells us, please add an environment map. This node has no effect without an environment map. Okay, seems pretty clear cut. We need an environment map. So let's import one. So double click, top, and movie file in. We have a banana, which is technically not an environment map. We could use that to light a 3D scene, but I'm not sure how it's going to look like. Probably not that good. So let's use a proper one. So if you click on the small plus here, you can select an image that is going to be a bit better. And in our case, we want to use, well, there's already an environment map integrated with TouchDesigner. So you can see the environment maps are looking a bit different than normal image. It's because you have to basically map the image to a sphere. So it's gonna look in a certain way, because an environment map or light is basically just a huge sphere that is around our 3D scene, and that shines the light that is coming from the image inside our scene. So there's nothing else than that. And we can then put the movie file into the environment map. And this. And you can see we have no color because I'm missing a material. So environment maps work only with physically based materials. So we need to set that up anyway. So I'm gonna double click, go on matte, select PBR, and use it as a material. So you can see already the light is being shown on our sphere, and there's not much happening because we don't have materials. So I'm gonna add all the materials we need. I hope I have some here. All the textures, I mean, sorry. Yeah. Six shaded. Cube matte. Sphere matte. Here. Yes, perfect. Ambient inclusion, sphere matte. Okay. So first I have the ambient inclusion, which is looking like this. So I add it to the ambient occlusion map. Then another movie file in, and then I need base color. So our sphere is going to be golden, basically. So the base color map. Then I need another one movie file in, and it's going to be the heights. The height is going to be the same all around the sphere, so you can see it's a constant gray. But actually, we don't even need that. Then you need what's a metallic. Movie file in. Then we need metallic normal map. Oh, this is looking a bit weird. Is it the right one? Okay. Yes, it's proper one. We're gonna add some roughness. It's a lot of material. It's a lot of textures to add, or a lot of maps. Okay, starting to look like something. I'm gonna add the attributes as we did before. Tangents. What am I missing? Specular level. And this material doesn't have a specular level, so we're gonna keep it as is. So here you have it. We have our sphere that is shaded by a physically based render material, PBR, and being illuminated by this environment map, and it looks like this. It looks a bit weird though. But yeah, it's how it's supposed to look, because yeah, there's some kind of issue which I'm not sure about right there. But you get the gist. You get the concept. Usually it looks a bit better than that. I'm not entirely sure why it looks like that. There's probably some error from my side. Yeah. Give me a minute. Maybe I can find why. Yeah. Anyways. Okay. So we've gone through the environment light. Maybe I'll show you some example how it can really look like. Map lighting. Yeah. So you can have a 3D object looking like this. So if I zoom in a bit, you can see. So the image in the background is basically the environment map, and you can see the reflections from that environment map, and also the sun that is coming from here, and shining on this 3D object. So if you have, it can add a lot of realism to your scene. Yeah, you should just check it out and see how it looks like. This is the best way to add some realism, yeah, to the scene. Okay, what else? Do you have any questions right now, or all good? Okay, I think this is all good for now. What else? Okay, the materials. Yeah, we're talking about the light materials. Different type of materials. I'm just gonna copy this plot. This. And 2, 3. And we need a light. Bit 2. Okay. And a. Okay, so we're still talking about the materials. We're going. So the next after Phong would be point sprite, which is basically just a point, which doesn't make a lot of sense in our case. In this case, because that means that the 3D object is going to be replaced by a small by an image, basically. So in this case, it's a round white circle, and if I change this to a box, so if I change the sphere to a box, it's still going to be white because that's how it is. So you usually use it for when you have a lot of 3D objects in your scene and you don't want to have too much heavy computation on each and every 3D object. Mostly use it for particle systems, and and things like that. Point sprite, in this case, it's almost the same as a constant, but they have a bit of different parameters. Yeah, I haven't played a lot either with this, so I'm not really the best to talk about this one. So select is just a utility operator. So you can have material on one geometry at one side of the project, and you use the select one, so you can select it without having to drag a huge cable through the whole project. Or if you work in different levels in TouchDesigner, you can use this to select a certain point, a certain material. Switch is basically like a switch, so you switch between one material and the second material. Yeah, I think that's as easy as it is. And then you have the wireframe material. Yeah, which shows you well the lines that are behind your 2D object. It's a bit the same as the lines material, but not exactly. So if you look those two next to each other, so it's a bit it's more about it's more how I mean how can I explain this? So the wireframe is basically something that is integrated in the graphical programming system that is behind everything. So you can have either triangles, or you can have squares, or you can have lines, or you can have points. There's like 4 different modes of representation of a 3D object in the background in the graphical system in the back. Wireframe is the line version of this. So, but the line material in TouchDesigner, so it's not wireframe, but it's line. Basically, just makes lines out of your 3D objects, and that means that you can also have different parameters on those lines depending on the position of your camera. So if you're further away, the lines are going to be darker. If you're a bit closer, the lines are going to be lighter. And yeah, and you basically can configure everything. You can configure distance, far, near. You can configure all of that. You can remove the lines if you want, or if you want only points, you can have. So you can have points basically only. Or you can have points and lines, so it's not really clear, so I can make the lines a bit bigger, the points a bit bigger. So you can see here you have points and lines, which can be pretty cool for whatever you want to do, and you can change the color of those points. I want them red, here you go. Which is not possible with the wireframe material. And as you see here, I'm zooming out of the object, so the object goes a bit darker. And if it's near, well, it goes like this. And you can change also the color of what color is it when it's near, and what color it is when it's far. So in this case, it's red when it's near, but I'm gonna do purple when it's far away. So here you go. I'm far away, so all the dots are gonna be purple. And when I'm near, all the dots are going to be red. And as you turn the object, the nearest points change, so you can have nice effects just with that. Yeah. And there's a lot of combination like that. And if you don't want points, or if you don't want lines, you can have vectors, which are basically related to how can I say that, to the normal vector. So the normals I was talking before. So each point in, or each point in your 3D object has a certain direction. And it points it points in a certain direction. So if you want to use vectors, it's going to show you the direction of that normal vector. This is getting a bit complicated, so I'm not going to tell you too much because it gets confusing else. But yeah, aesthetically it's pretty cool. So you have the same principle when near and when far. So it's further away, it's purple, and when it's near, it's a bit more red, and etc., etc. And then you can combine everything together if you want to have fun. Then we have points. Here we go, and then we can add the lines also. I mean, combinations are endless, basically. Yeah. And how does that look applied to our cube? Because we were just working on the material. So the cube looks like this. So remember, we have only the vectors right now. If we want to remove the vectors and we want to have points, here we have the 4 points of our object, and we can add the lines. We're gonna change the points to red again. Here we go. Yeah. So the further away, the more purple. Yeah. Okay. I think I spent a lot of time talking about the lines. Oh yeah. Last difference is if you want to use a wireframe. The color is always going to be constant at any distance of the object. Plus, it shows you how really the object is done in a geometrical, on the 3D programming language that is behind the scenes. So usually, a square is not made out of 4 points. It's basically 2 triangles put together. So it's a bit like this is not made out of a single square, but it's made out of 2 triangles that are like this. So one like this and the other like this. But that's 3D 3D geometry, like basics. Yeah, so it's just it's good to know, because if you want to get a bit deeper at a certain point, you might need to use this in calculations and things like that. So it's it's not so important at your stage, but it's good to keep in a certain corner of your head. Knowing how it works on the ground up is good, because then you can build up on that ground and also debug stuff when you have really issues. And materials. Yeah, I think that's it. Okay. I think I've gone through most of the stuff in terms of 3D object and materials. What else can I show you? I can show you how it looks like when this is a video. Do I have a video here? Yeah, I have one here. So here you have. So I'm going back on the cube we had before, which is now a plane actually. So the plane, and we have a texture that is applied on it with a normal mapping, which shows us the direction of the reflection of light, and we have a height map, which allows us to change the shape of the 3D object. And we have a emit map, which allows to put certain lights at a certain spot on this. Also, you might wonder why this is square and our texture is like full HD, so 1920 by 1080 resolution. Well, simply because we apply a rectangle texture on a square object. So if you want to have this as a square, well, you need the same ratio as the texture. So in our case, it's going to be 1.92, so, and 1.08, and then you have exactly the same ratio, and you have the proper size, texture size, and everything. So you can see it's already, yeah, it's already a cool effect. I'm gonna save that and VCA residence, and I can send it to the channel if there's some interest. There's always, it's always good to have some point of reference. Yeah. And you can see, okay. Also, when I'm moving inside a 3D object like this, it will not change the camera. Because obviously we're just looking at the 3D object as it is, but we're not looking at the geometry. So the geometry in our scene with the camera. So we're not changing basically the camera. So if I want to change the camera, I need to activate the camera, and then I can turn around, zoom in, and yeah, you can do that. So you can change the parameters manually, or you can also use translate, rotate, and scale. So translate means the position in space. So yeah, if we have our camera here, translation means that you can translate it from here to here, from here to here, from here to here, or well, wherever you want it, basically. Rotation, I guess this is pretty clear. So it's always going to be like there's a rotation on like this, there's a rotation like this, and there's a rotation like, I don't know actually. I don't know the third rotation. Yeah. And scaling, well, in the camera it doesn't change a lot. But if you use a scale on the geometry, well, it changes the size of the object. So if I want to make it a bit smaller, you can make it a bit smaller here or a bit bigger. It can go over 1, obviously. I mean, not obviously, because you're limited to 1. So, but if you have parameters that are limited to 1 in the window, you can set them. Usually, you can set them to higher than it's shown. So in our case, it's limited to 1, but you can go to 10, 100, whatever you want, basically. Yeah. Okay. I think I've done most of it. Anything you want to learn in the 5 minutes left? Anything I can help you with? Any questions? Or should I show you one last thing? Somebody's writing on the chat. Thank you. Okay, no problems. Okay. Maybe the last bit of information that is really important in TouchDesigner. This would like need a whole session itself, but as I'm gonna deliver the file, I might as well include it into it. What happens if you have something that is an image that is not moving, that is a video, but you wanna move it from left to right. So let's say we have this flower image, and you want to move it from left to right on a constant basis. Well, then you would do something like right. So you go on the 2 bars here, right click here, and add a transform. And that means that you can transform the texture. So you can basically rotate it, and you can see it's directly reflected on what is rendered. You can scale it, you can translate it, etc., etc. Okay, so we're gonna just re-rotate it. Okay, and in TouchDesigner, there's one big concept, is that everything can be changed by everything. So if you want to move, if you want to translate an image, depending on the time, well, you can just do that basically. So if you want this image to go from left to right, based on the time, yeah, you can do exactly that, and you can do a lot of different things like that. So every parameter can be changed by another parameter inside TouchDesigner. So in our case, if we want to translate the image from left to right, I'm going to use something that's called a Python expression. So seconds. And there we have an issue because it's not, because basically right now the texture is like a frame, and inside this frame you move the image, so you move from left to right or back up to bottom, but you need also to repeat that image, so it's always going to be like repeated. So you click on tile, you click extend repeat, and you're gonna have this image repeated forever basically. And here you go. I'm just basically translating the image from one side to the other forever. And if I want to have this image mirrored, well, I just choose mirror, and then you have something that is a bit nicer, and that is being applied to our 2D object. Yeah. In this case, we can see that the color map is not the proper one, so we just change that, and then we have so we have this happening. So that's already a huge start into generative art and TouchDesigner and 3D basics. Hope it was basic enough and that I explained everything as well as I could. Okay, and now I can only recommend you to, if you're interested in more, yeah, lots of tutorials on rtd.org, which I already posted, which I'm going to post again because I'm not sure everyone was there last week. I think I see most of the names actually. I'm not sure. And practice, work a lot, and don't be afraid to do mistakes. Yeah, and I think this was it for me. So, anyone has last questions? Somebody's writing on the chat. Okay, that's a nice compliment. Thank you. So, yeah, more comments. And obviously, you can always contact me if you want. Twitter, Discord. I'm not super active on the VCA one, but I'm always on Twitter. Yeah. I can give you feedback also on your artworks if you want. Just hit me up. I'm there for most of the stuff. And more comments. Yeah, thank you to have assisted to my class. And don't be afraid to contact me. And have a great day and see you around. And I hope you're gonna be NFT rock stars. Hope that and everything's gonna work out. Bye bye, guys. See you around.